And I'll also mention before we get going, there are no quizzes this week. We're free of quizzes. Next one coming up, if you guys want to know, next one coming up, last names L through Z. So you guys in class right now, Tuesday. Quiz number 1 on Tuesday, A through K, and remote students Wednesday next week. All right, that's my plan for the next upcoming quizzes. All right, L through Z on Tuesday in class. Everybody else, A through K, and remote students Wednesday. Next Wednesday, everybody. All right? All right, let's get this show going. You guys can see Unit 9. We are flying, by the way. We are still a week ahead of where I've been in past years, and that's just because we haven't had the midterm. So that's great. I still don't know if we're going to be taking this Regents or not. Some people say yes, some people say no. So when I get final word, we'll figure it out. But if we're keeping this pace right now, we're going to have a lot of time to review and get prepared for it. So what's up, Emma?
Sorry, I got it on packet time.
Yeah. By the filing cabinet there. In the box. All right, so we'll see when I get information about the Regents exam. I will definitely pass it along to you. So we're on Unit 9. There's only 12 units. And we're just in March 1st too. So, but this unit's not bad, but Unit 10's a long one. All right, Unit 10 is going to be a long one. All right, so let's talk transformations in general, and then today we're going to focus on a specific transformation. All right, so what is a transformation to begin with? Here's what a transformation is. I'm going to take a point, maybe a couple points. All right, so I'll just have point F. And what I'm going to do, I'm going to move it around. All right, I'm going to move it around. How I move it? Who knows? I may slide it. I may go up and to the right. And I end up with this point here. Maybe I'll do that. Maybe instead, I'll rotate it. And I end up with my new point right here. Or maybe, like we're going to do today, I'll take a line and I'll say, flip it over that line for me. But we don't use the term flip. We have a big boy, big girl word, which we'll use in a second. These are all transformations. Okay? These are all different types of transformations. There are some that we're going to do that after I'm done, the lengths are the same that I started with, and so are the angle measures. And we have used this term. It's probably been months since I've used this term. I think I used it in Unit 4. When I perform a transformation and everything stays the same, the lengths stay the same and the angles stay the same, I call that a rigid, anybody remember? Motion. Yep. That's a specific transformation after I'm done moving all the points, the original figure and what I end up with are congruent. So the lengths stay the same, angle measures stay the same. And we did talk about this because I remember saying, hey, there's one that doesn't do that, right? There's one transformation where the original and what I end up with don't look the same, and that is a dilation. Makes it bigger or smaller, so they're not congruent. But I want you to keep in mind, and this is what we'll fill in the next blank with. A dilation will not preserve the length. The length changes in a dilation. But what does stay the same? Angle measure. All right, angle measure stays the same. So just to keep that in mind. So we do not refer to a dilation as a rigid motion because the lengths do not stay the same. And 2 more vocabulary terms. I'm sure when you guys used to do this at the middle school, tell me if they didn't use these, please, if they didn't. What I start out with. So I start out with a triangle that I'm about to rotate, or a triangle that I'm about to dilate. The figure I start out with, I'm going to start calling my image. My pre-image. That's the figure you start out with. Then you transform it. You slide it. You rotate it. You dilate it. You flip it. What I end up with is called my image. So what I start out with is my pre-image. What I end up with is my image. All right, so I'm going to start using that vocabulary in this unit. All right, real quickly on the rigid motions. Take a look. Number one, I got two triangles. The one on my left is my pre-image. The one on my right is my image. Did I perform a rigid motion? Did I perform some type of transformation where side length was preserved and angle measure? Does it look like I performed a rigid motion here? Woo! Here we go. Let's hear some voices today. 10 spot. Atticus, did I perform a rigid motion here?
No.
No. Why are you saying no? Because you're correct. What did I not preserve here? Distance or side length or angle measure?
You kept the angle measure.
But what else? What's different now?
It's smaller.
It's small. Correct. Different side length. Side length was not preserved. Also, it's kind of convenient, Atticus, that your number came up first. Heads up, your calculator's in class with me. All right. So if you were panicking, it's in class with me. All right.
Okay.
You're welcome. All right, so side length not preserved can't be a rigid motion unless side length is preserved. All right, what's 2 look like? Look like I performed a rigid motion on the pre-image on the left to the image on the right? Yeah. Looks like angle measurement stayed the same. And I'm just by looks, we're not exact here, but it does look like side length was preserved. So this will be a yes, it is a rigid motion. Yes, side length and angle measure are preserved. So everyone all right on this concept, rigid motion? I'm going to look at one of them today. If I flip the figure, does the size or shape change? Does angle measurement or side length change if you flip a figure? No, but we're not using the word flip. Can we use a big boy, bigger word? And that would be reflections. Reflections. How do you know a reflection's going on, or I'm asking you to reflect something? I'm not going to write out the word line reflection. We don't have time for that. So instead, we're going to use the symbols instead. The symbol for reflection, lower case R. Well, can't I just put an uppercase R, Mr. Carlino? I know R stands for reflection. No, uppercase R is for something that's coming down the line. Right? This stands for lowercase r specifically for reflection. Also, in addition to the lowercase r, you guys know what I mean when I say the word subscript? Subscript at the bottom. You'll also see a subscript at the bottom of that lowercase r. Something will be written here, which is your line of reflection. You're never going to see this line of, you're never going to see line of reflection written. It'll tell you, hey, reflect over this line. So for example, here you go. Here's an example. Reflection over the y-axis. That's what you'll start seeing. Okay, that's what you'll start seeing. Whatever is down in the subscript tells you the line you're going to reflect over. All right, you ready? Let's start reflect. Some of this is going to be real easy because it's back from your middle school days, but some of it may be a little challenging because it is honors, right? All righty. So I have this point, A, 2, -1, and we're going to do a couple things to it. So you might as well start. Everyone go ahead and graph 2, -1. Call it point A right next to it. All right, we're going to do a few things to it. Look at the first one. I'll just put number 1 here. Look at number 1 here. See the symbol now? Reflect it over the x-axis. Reflect over the x-axis. I still want to go over this slowly, even though I know many of you know how to reflect it already over the x-axis. Remember, when you do a reflection, because it's a rigid motion, distance stays the same. Distance stays the same. So how many units is A away from the x-axis right now? Ellie, how many units is A from the x-axis?
1.
1. So that means when you reflect it, you should also keep the distance the same and go 1 unit away from the x-axis in the other direction. 1 unit away. 1 unit away. So there's its reflection right here. Now, how do I call it? Because it's not point A anymore. It's a new point. I'm going to call it A. Anybody know the marking symbol, what it's called after I transform a point? Because I don't want to call it A anymore because it's not. A is 2, -1. This is a new point. A
prime.
prime, is that with a little, is that what you were thinking? Looks like, okay, never mind. Yes, A prime. A prime. So going back to number 1 here, I could say after I reflected in the x-axis, A prime becomes the coordinate 2, 1. 2, 1. Is everyone all right? Just reflecting it over the x. Okay, before I move on, don't get ahead of me. Very lightly, so you can barely see it, can you connect A and A prime right now? Very lightly. You're going to make a segment. Make segment A prime. Very lightly, so you can barely see it. I'm going to erase mine anyway. So, all right, everyone see the segment you created? What line did we just reflect over? The x-axis. Everyone look. The x-axis is the, well, I'm going to use a vocab word from the beginning of the year. The x-axis, the line we reflected over, isn't that the perpendicular bisector of AA prime? Everyone see it? It's definitely perpendicular because it forms a what? Right angle. And what's bisect mean again? Cuts it in half. Goes right through the middle. Does everyone see that? At the x-axis, the line we reflected over, is the perpendicular bisector for AA prime. Good? All right, I'm going to keep harping on that.
What is perpendicular thing? What is perpendicular?
Okay. So what line did we just reflect over?
If you're asking me,
Yeah.
the x-axis.
X-axis, right? So look at the x-axis, Sophia. It is perpendicular to AA prime. Agreed? Because one's horizontal and one's vertical. And the x-axis is going right through the middle of AA prime. So here's new markings. It's being bisected. Agreed?
The x-axis being bisected? Or
No. AA prime is being bisected. The x-axis is the perpendicular bisector for it.
Oh, all right.
All right, the x-axis is acting as the perpendicular bisector. Everyone all right? Okay, next, go down 1. Go down. Don't go across, go down. Now reflect 2, -1. Let me get rid of my markings here. Take 2, -1 and reflect it over the y-axis now. Over the y-axis. All right, how many units away is it from the y-axis? A is how many units away? Because I want to keep it the same. Sabrina, how many units away? 2? Everyone go 2 on the other direction then. Distance stays the same when I do a rigid motion. There it is. There's A prime, which for us now looks like what? -2, -1. And again, I could ask people what the coordinate is, but let's save some time. All right, everyone stop. Again, can you lightly connect A and A prime again? I'm just trying to get you guys the definition, what the definition of a reflection is here. So again, very, very lightly, everyone, connect AA prime. What line did we just reflect over? Y-axis. What's the y-axis doing to AA prime? It's a perpendicular bisector, isn't it? That is every time the line you reflect over will be the perpendicular bisector for that segment you created. Every time. The line of reflection is also a perpendicular bisector, as I'm starting to prove to you now, and I'll prove to you one more time in the next one. All right, go to the bottom right. Bottom right. Y = 2. Ooh, oh, maybe a little tricky for some of us now. It's not the y-axis, it's not the x-axis. Do you guys, anybody remember from their graphing days what type of line y = 2 is? Go ahead.
Horizontal.
It is a horizontal line, in this case, going through Where on the y-axis?
2.
At 2 on the y-axis. All right, so take a look. If you don't know what I'm talking about, a horizontal line going through 2 on the y-axis. That's the line y equals 2 right there I graphed. Okay, everyone see that? That is the line y equals 2. Now, if I had x equals 2, vertical line going through 2. All right, count the distance. When I reflect, distance stays the same. How many units away? 2, 1. Here we go. Zach, what do you got? How many units away is it?
3.
3. So everyone go 3 in the opposite direction. 1, 2, 3. Boom. There it is. There's A prime. Which looks to be 2, 5, according to my graph, 2, 5. And last time I do this with you just to prove my point. If you connect them now, if you connect A prime, what's y equals 2? The line I reflected over, that's a perpendicular bisector. Every time, the line of reflection will be a perpendicular bisector. All right, one more here, and then now we get crazy. Nuts! Let me regraph my A point. Let me get that horizontal line out of there. Ooh, what about this last one that I specifically saved for last? Y equals x. What the heck does that look like? Well, here you go. I don't need you to get it out. I got my handy dandy calculator here. Ready? Y equals x. That's what it looks like. Oh! It's not horizontal or vertical, is it? Oh boy. Take A and reflect it through that line right. Oh. Uh-oh. Guys, we're not counting either. Oh, it's 2 units away, so I'll go 2 units in the other direction. I don't think so. Unfortunately, we can't count, so this is the one instance right now out of 2 today that I'm going to have you remember a rule. All right, I'm going to have you remember a rule. This is one instance. Number 2 is coming down the line at the end of the class. So when I reflect over the line y equals x, and I'm going to take 2, -1 and do it. Here's what it's going to become, and here's the rule. I really don't want to give it to you. I kind of want you guys to come up with it. Ready? Say the line we're reflecting over. The y is equal to the x. What was my x coordinate here? 2, so that's equal to my new y. Go backwards now and read it. The x is equal to what my old y was. So basically, in a nutshell, can somebody summarize, when I ask you to reflect over the line y equals x, what do you do with the coordinates? Switch spots. Okay, switch them. Yep. And look, graph it now. -1, 2. Does it look like I flipped it over that line? You're darn right it does. I guarantee if you tried to fold your paper along the line y equals x, A and A prime would smack right on top of each other. All right, so that is the rule. When you reflect over the line y equals x, you switch the coordinates. That's it. Y equals your x and your x equals your y. You guys good? Questions about those? Because I'm going to go a lot faster now. All right, go ahead. Number 1. Example number 1, graph triangle ABC. Go ahead, graph triangle ABC, and then flip it over the y-axis for me and give me the coordinates in A prime, B prime, C prime fashion. Y-axis, Y. Don't flip it over the X, Y-axis.
A quick question for the homework. When we do the homework, does it matter if we just draw the lines ourselves, or should we like be using a ruler to make sure they're straight or something?
Right now, I don't care. No, ruler or not, or you freehanded, it doesn't bother me. Because what I'm really going to be looking for is what your graph is and what coordinates you ended up with. Okay, so you guys are reflecting it over the y. So you got A prime, C prime, B prime. Okay, let's do this. A prime, B prime, C prime. What do we end up with? Ooh, here we go in the hat. Luke, here we go. What do you end up with? A prime.
-1, 6.
B prime.
-4, 3.
And C prime.
-2, 1.
Good job, Luke. Thank you. Everyone all right? No issues? Okay. Only gets a little crazy when it's not the X or the Y. It's just Y equals a number, X equals a number. Speaking of that, here we go. We're going to do a couple things to point X here, it looks like. X, 0, 5. In all seriousness, honored kids, do we know where 0, 5 is? It's on the Y. I almost tricked myself there. It's on the Y axis. Not the X axis, the Y. All right, X equals 2. We talked Y equals a number before. X equals a number is a vertical line. So a vertical line right here. That's X equals 2. Count the distance. Move that many on the other side. You got it? You got it? So there's X prime. And I'm not even going to ask anybody because you guys can just read numbers off that grid. 4, 5. Now, be careful now. Here we go. We're not going, in part B, we're not going back to 0, 5. It says reflect X prime. So now everyone go to 4, 5, and we're going to reflect it through the line Y equals -3. If it's Y equals a number, we talked, hey, it is going to be a horizontal line. In this case, going through -3. Oh, I got a little tricky on some of you here. Let's see if you can pick up on it. So X prime reflected over Y equals -3. So count your distance and match it. Hopefully we don't enter panic mode when we start counting on the other side. Oh boy. Oh boy, I'm running out of spots. Can I do the numbers in my head? Or do I need to add on to the graph? I hope not. I'm hoping we're not doing this. I need more. All right, well, what if the distance was 50? You're really going to put that much more out? No, you're not. So hopefully we're not freaking out here. All right, we don't need to add on to the graph because what'd you guys find? What was the distance from X prime to the line of reflection? What's that distance? 8 units, right? So that means I got to go 8 units from -3, right? From -3. You don't need to add on to the graph at all. No reason to panic. Where would you end up? What do you got, a X coordinate?
4.
4, -11. Now, what should I call that point?
X prime.
X double prime, correct. Anytime I transform or move the prime coordinate, I now go to double prime. Right? Anytime I move the prime coordinate, I go to double prime, and then the triple. Yep, we'll get into triple prime soon enough. Any issues there, even though you ran out of room on your graph on purpose? All right, nothing? Anybody at home going? How we got to -11? All right, let's go back to those diagonal lines now, reflecting over the diagonal lines. This time I want you guys to reflect a segment. 3, 0, and 4, 3. You guys are starting to see more and more, right? The new notation, lowercase r, y equals x. So that means I want you to reflect over the line y equals x. I had you, this was one that I showed you earlier on that, hey, I just said, hey, know the rule. Because it's kind of hard to reflect over a diagonal line. So somebody remind me, what was the rule again? If I ask you to reflect over y equals x. 1-6. Kyla, what was the rule?
You have to flip the numbers.
Correct. Switch the coordinates. Perfect. Okay, so let's switch them right now. F prime will become 0, 3. G prime will become 3, 4. All right, all good? Okay, coming up now is the second instance where I'm going to ask you to remember a rule. So y equals x, I switch the coordinates. If I could spell the word switch. Now that I look up there. There we go. Now I want you to reflect over the line y equals -x. The original coordinates f and g over y equals -x. Well, what's that line look like first? Remember, that was y equals x. -x, going the other way now. Now we're going the other direction. We're having a negative slope now. Ooh, so what do you think? What do you think I'm going to ask you to do the coordinates here? Well, it's still a version of y equals x, isn't it? So I'm still going to ask you to switch coordinates because it's still a version of y equals x. But there's something in addition to switching the coordinates when you reflect over y equals -x.
After you switch them, you turn the x negative. When you make the x negative.
Yes, and then there's more. Okay, there's more. Make the x negative, and here's why, Maeve. That's what you guys see. You see the x being negated. Well, I could also divide by -1. And guess what? X equals. So not only am I going to negate the x, I'm going to negate both of them. Okay, so switch coordinates and negate both. Hey guys, and that's the only two rules I'm going to have you remember. That is it for reflections. That's it. Go ahead.
Negate both mean multiply both by -1.
Correct, or just change the sign of both of them. Yes, correct. Yep. So for here, f prime now, take a look. Will be flip them, 0, 3, and negate them, negative. 0, -3 would be f prime, and g prime, switch them, 3, 4, and negate them, -3, -4. So 0, -3, and -3, -4. And you guys can see, let me throw that line in there now. There's y equals -x. It looked, flip it over. It does look like we flipped it over correctly. Distances don't look like they changed. So everyone all right on the two that I'm going to have you guys remember rules for? Radhika, go ahead and then go ahead.
If the y was negative, would you still like make them both negative?
It's still you said y, like if I wrote negative y equals x, it's the same line.
Okay.
It's the same line.
Okay.
So the rule would be the same.
Okay,
Yep.
and what if you were to make them like negative y equals negative x? Or is that not a thing?
That's, if I have negative y equals negative x, watch, that's the same as, all right, I want to make
Am I
this,
just switching now?
that's what, if I'm going to divide, that's the same as y equals x. Same
Okay,
line.
So it's the same rule.
Yep.
Well, so let's say we get like the question reflect FG over line y equals negative x. Will we ever have to show the work of us like switching and making it negative?
Nope. I just know you guys know the rules, so you're just going to apply it. Good questions, guys. Anything else? Go ahead, Dave.
Do we always have to graph it? Like, or can we just write down the?
It depends on the directions. If the directions on the homework in the textbook tonight say graph 2, you got to graph. It's not going to be optional. Anything else? I really thought this fourth period class was going to give me another question. What if it's just some other random diagonal line other than y equals x or y equals negative x, right? Because you guys have graphed more than, like, what if I ask you guys 2x minus 1? Reflect over that line. That's tomorrow. That's honors level reflections coming tomorrow. You guys just worry about horizontal, vertical, y equals x, y equals negative x. That's what you're good with today. And finally, last thing I need, I've been providing you guys with the line of reflection. You tell me what I reflected over in the last one. So I give you a triangle ABC, and I give you its image. Its image, A prime, B prime, C prime. And it's a reflection. Where's the line of reflection then? So just a little reverse. Going in reverse. Now you guys get me the line of reflection. All right, what do you got here? Those are I graphed both the pre-image and the image. So what line does it look like I reflected over where distance did not change at all? Here we go. Lucas, what line did it look like we reflected over?
The x equals 3.
There you go. Vertical. Well, it was a vertical line. And we talked today. Anytime it's a vertical line, it starts with x equals, look where it goes through, 3. Yep. And hey, if you connected B and B prime, A and A prime, or C and C prime, that line's going to be a perpendicular bisector for it. All right. Last thing about homework. Yes, it's all on graph paper. Please do a graph, a separate graph for every problem. So when you do, I don't know, what do we have, 5 through 9? What's that say, 5 through 9 odd?
Yeah.
Okay, don't do 5 through 9 odd on the same XY axis. Have number 5 on a graph, number 7 on a graph, number 9 on a graph. Okay, separate graphs for every problem if you have to graph. Yep.
So every question can need a separate graph?
Correct.
Or do the, like they
I don't know. If it says graph, it's not optional. Okay? If it doesn't say to graph, that's up to you. All right, but when the directions say to graph, you have to graph. Okay, thanks guys. You can get started on that if you want. You can sign off. I'll see you guys tomorrow. All on graph paper, no credit, remember. Let me look it up.
It comes up and asks them. Not all the time. I think it's the lowest. I think it's just the highest grade and the lowest grade. I know it used to do that.
I don't, for mine, it does, I know for mine, it doesn't do highest and lowest.
Yeah,
I wouldn't do that. I don't like that.
Like so bad, you're like, okay, you got the lowest score, congratulations.
Exactly. I mean, it doesn't say who got the lowest score.
Well, you know
Well,
it's
it says
you.
that somebody did. And well, yeah, you got a bad score.
I know.
We are at out of 30 points, 27.74. So whatever.
What was that? 27.74 divided by 30. 93. 92.4, but 93 is.
92.
That's good.
Oh, okay, 92.
There you go.
What's like the lowest one we've had so far?
I have no idea. I really, to me, your overall average is what I really am concerned about, like what the overall class average is, just to make sure it stays where it's been in years past.
What would you say that is, like an estimate?
Usually anywhere from a 90 to a 92
That's not too bad.
for every quarter should be the class average. And then you guys lucked out on the midterm because the midterm usually is about an 83 or an 84 class average. So
Yeah.
because it's pretty
That's not
darn
very exciting.
tough.
Yeah, but we didn't have to take it, so. Yeah, but like I feel like the midterm basically just preps you for the regents, and the midterm's like harder. Yeah, but like exactly. But we're going to take the regents. It's like we've never taken one before. We took we didn't take it last year. Midterm though.
Yeah, but that's.
Yeah, but that midterm was like easy. Yeah. Like, it wasn't that hard, I don't think.
I think I got like
I got something like that.
I think I got a 90.
I'm pretty sure I actually think I got like something around a 90. I think I got 90. Hold on. Okay.
I remember the first multiple choice wrong.
Oh, I remember I was trying to do all the multiple choice as fast as I can, so that I'd actually finally the short one. We have so much time to that fast.
We're gonna have been there for like 18 hours.
No, I'm definitely finished. Oh my god, check your grade from the previous year. Yeah. Well, I don't know. I don't know what I'm doing. I think I got like a 91.
See, I got like an 89 on like the multiple choice and then like a 92 or something.
I remember all my mistakes were like horribly stupid. I was so mad about it.
I remember one of them, I was like, this one or this one, or this one or this one.